This is Mech 130 motors and drives. Here we have a stepper motor. The potentiometer engages the motor once it passes an analog reading of 10. We start spinning. We're up at full speed. We can easily adjust this depending on the analog reading of the potentiometer. Speed's changing, as we can visually see. We can go down to a very low speed or very high speed. If we spin the potentiometer below 10, as we can see, we're now going backwards. And we are slowly going up in speed as we spin the potentiometer and the analog reading increases.
Now we look at the code that was involved with the stepper motor. First we see pin 7 is being used as a permanently low enable pin. So if the enable pin isn't high, then it will turn it to low. Now the inverse, we see pin 12 is being used for high enable pin. We have our analog input, that's going to be the speed knob. We have our direction pin, which is pin 13. We have our steps per revolution. We have our true and false statement, our boolean, which is direction. We have our step count. This is the number of steps the motor is going to be taken. So here we have our coils. We have coil A and coil B. These are opposites. Our serial baud rating begins with 9600. This is the speed that the code will be read at. We have our analog input. We have our output to our low and our high. We have our output to our direction pin. We have our digital write enable pin high, and then we have our digital write enable pin low. We are using the stepper library here in some regards. So now we first see our void loop. We take our sensor reading from our analog input. This is mapped using the library, taking the sensor reading from 0 to 1023, and then 255. Our if statement takes the sensor reading, and if this reading is above 10, and if the direction is true, then the motor will begin moving forward. This is actually connected down here, and if the direction is the opposite of the direction, then it's a true statement, which goes back up into this boolean of direction. So then our direction pin is signaled high, and our speed is set at our sensor reading, and then this positive number is the positive steps taken forward. Then we have our analog write. This is our sensor reading being taken again, and then the speed. And then this is going to print into the serial monitor that we're moving forward. And then there's going to be a delay. This delay is just so the motor has time to stop before changing directions. So once we get to the direction pin being low, and the sensor reading has been taken at once again below 10, right? So that's that analog sensor reading of 10, as we could see in the prior videos that were made. If the sensor reading was below 10 and then it reached the threshold of 10, that is when the motor changed direction. And this is going to move at a negative 10 steps. So this initiates the negative 10 steps. For our speed, we used a for loop. This for loop starts at 0, and we add what our I is, 0 plus 1, until we reach the number of 9, and then at 10 it repeats. And we have our digital write of 10, and our delay of 1 second, and then our digital write 10, low, and then we have a delay of the reading. And that's basically how. Here we can see the driver that was used to drive the stepper motor. First we see the pulse that was involved with the step count. Then we see the direction pin. This was involved with changing direction. And then we see the enable pin, and this was used to jump the motor, or could be used to jump the motor. The second pin, the negative, was used as a ground, or a negative in this case. And how these kind of function is almost like an LED. We give it an analog input. This analog input is red, and then the circuit is complete.